Hello, this is your 6-4 Properties of Rhombuses, Rectangles, and Squares video. These are your, listed are 3 of your theorems and then your definition of a rhombus, a rectangle, and a square. So you need to make sure that you know the difference between a rhombus, a rectangle, and a square. It's very important that the differences are noted because when you're solving a problem, you need to make sure you know the differences between them, because the characteristics of one may not be the same as the characteristics of another type of quadrilateral. These are called special parallelograms, which means they have the properties of a parallelogram plus special or extra stuff, I should say. So for example, a rhombus still has the same characteristics as a parallelogram, but it doesn't have the same characteristics as the square does. However, they do both share the parallelogram. So it can get a little confusing, but just remember that all 3 of these are parallelograms. They're all quadrilaterals, but they all have distinct differences between them that make them different than the others. So a rhombus is a parallelogram with 4 congruent sides. A square is a parallelogram with 4 congruent sides, but it also has 4 right angles. And a rectangle has 4 right angles, but that's it. It just has 4 right angles and 2 opposite sides are parallel and congruent. So they have their own little differences. You just need to make sure you know the differences, because that will help you with these problems. Theorem 6-13 is our first theorem. It says that if a parallelogram is a rhombus, then its diagonals are perpendicular. That's going to be important. For this theorem, remember the perpendicular bisector theorem. And if you don't remember what it actually says, go back in your notes, or you can Google it. You can go on Pearson and look it up. But recall the perpendicular bisector theorem for theorem 6-13. Theorem 6-14, if the parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So if you look, angle 1 and angle 2 are congruent, angle 5 and angle 6 are congruent. Now we also know that opposite angles are congruent. So basically 1, 2, 6, and 5 are all going to be congruent also. Same thing with 3, 4, 7, and 8. Theorem 6-15, if the parallelogram is a rectangle, then its diagonals are congruent. So basically, if it's a rectangle and we draw a diagonal from A to C and then from B to D, they are going to have the same exact length. Okay, so here's an example that you can do where you're practicing determining whether or not something is a rhombus, a rectangle, or a square. The best way to do this is to remember the definitions of each. A rhombus has 4 congruent sides, a square has 4 congruent sides and 4 90-degree angles, and then a rectangle has 4 90-degree angles. So based on the picture that you're given in any situation, and in this case you have this one right here, you need to figure out what you know in the picture, and then that will help you when you compare it to the definitions. It'll help you figure out which one it is. So in this one right here, what conclusion can you draw regarding the angles of parallelogram ABCD? In this case, they tell us that angle B is 90 degrees, and basically we know that all the angles are congruent and that they measure to 90 degrees. Next question is, what conclusion can you draw about the sides? And in this case, opposite sides are congruent, so we know that they're also parallel, so that's some other information. And we know that because it told us in the question that it was a parallelogram. So we know, based on what we have here, that ABCD is a rectangle. Opposite angles of the parallelogram are congruent, so the measure of angle D is 90. By the same side interior angles theorem, the measure of angle A is equal to 90, and the measure of angle C is equal to 90. Since parallelogram ABCD has 4 right angles, it is a rectangle. You cannot conclude that ABCD is a square because you do not know about its side lengths. We know that opposite sides are congruent and parallel, but we don't have enough information to determine that the opposite sides are congruent. We don't have enough information that all of the sides are congruent. So the question that I want you to bring the answer to class is the following. Can the parallelogram be classified as more than one of the quadrilaterals that's listed? So can you classify a parallelogram as more than one of the ones that we're talking about, a rectangle, a rhombus, or a square? Is that possible? And if it is, tell me which ones and tell me like the details and explain it. Okay, your next question, what are the measures of the numbered angles in rhombus ABCD? This rhombus it's important to know that it's a rhombus because then we know that the diagonals are perpendicular, and we also know that the diagonals bisect they're the opposite angles. So in this particular case, we are aware that the angle that is created by BD at angle B is 58 degrees, which means that the angle on the other side of that diagonal is also 58 degrees. And then, as you recall from earlier, I also talked about how those two angles would be congruent. These two angles would be congruent to these two angles because it's a parallelogram. Opposite angles are congruent. So we know in this case that angle 2 is equal to angle 3. And we also know that angle 2 is equal to 58 degrees, which means that angle 3 is also 58 degrees. Pretty simple there. In order to find angle 4, we would need to know what angle 1 is. We know that angle 1 is going to be a 90-degree angle because the diagonals are perpendicular. So we know that that's a right angle right there. And then we know that we can set up use the angle sum theorem, I should say. We know this is 90. We know this is 58. We can set up, using this angle sum theorem, we know that 90 plus 58 plus angle 4, the measure of angle 4, is equal to 180. 90 plus 58 is 148 plus the measure of angle 4, and the measure of angle 4 is equal to 32. Okay, our next one, what are the measures of the numbered angles in the rhombus PQRS? Same kind of concept here, except that this time we know this angle, and it doesn't really have a relationship with 3 and 1, except we do know, however, that 3 and 1 are the same thing. So you have multiple options here. One is to do 104 plus 104, subtract that from 360 since this is a quadrilateral, divide that number that you get by 4, and that'll give you each angles 1, 2, 3, and 4. Another option is to take 104 and subtract that from 180 and divide that number by 2, and that'll give you angle 1 and angle 3. So it's really up to you on which route you want to go, but the angle is going to be 38. Another way to do this is actually angle Q and angle P are consecutive angles, which means that they're supplementary. So you could do 180 minus 104. Let me write that down. 180 minus 104. And then that'll give you, same thing we did earlier, but it's a different, because we're using consecutive angles this time. And that gives you 76. And then angle 1 and 2 are congruent, so you can take that and divide it by 2. That would work as well. Okay, our last example in the rectangle to the right, keyword rectangle, SF is equal to 2x plus 15 and RB is equal to 5x minus 12. What is the length of a diagonal? We learned earlier that the diagonals of a rectangle are congruent to each other, which means that SF is equal to RB. And in this case, what that means is that 2x plus 15 is equal to 5x minus 12. Now you have algebra, solve for x, take your x, plug it back in, and you'll get your answer. Subtract the 2x over, you get 3x minus 12 on the right side, 15 on the left side. Add the 12 over, you get 27, and divide both sides by 3, and x is equal to 9. Take 9 and plug it in, 2 times 9 plus 15. That's 18 plus 15, which is going to be 28, 33. Okay, so that's it. Tomorrow in class, if you have any questions, please ask. If you need to come in the morning to ask me any questions, that's fine. And the next section is going to be taking this and going a little bit further, thinking about it in a little bit more deeper level, I guess you could say. So if you have any questions, please ask. Have a good night.